Hi, this is Cedric from the Network Security Group. Today I will present some results from the high-performance file transfer project. We developed the Hercules file transfer system to exploit SCION features for bulk data transfers. In this video I will focus on the performance results. First I will show that Hercules is able to achieve huge speeds when given the appropriate hardware. And then I'm going to show a real-world use case where Hercules can improve transmission speeds by a factor of 2.5. When you see the setup in our lab, you may think it is really easy to achieve rates near 100 gigabits per second. Unfortunately though, TCP, which has undergone heavy research in the past decades, is unable to do so. Even when tweaking TCP settings and switching to state-of-the-art congestion control algorithms, we could not get past 40 gigabits per second. And the main reason for this is simple. A TCP flow cannot use more than one CPU core. When dropping the in-order delivery requirement, we can not only get rid of the well-known head-of-line blocking issue, but we can also parallelize the packet processing of a single flow. By postponing retransmissions, Hercules gets less sensitive to packet loss and delayed acknowledgement packets. Let me show you the system in action. On the left you can see the receiver and its configuration, and on the right you can see the sender. Even though we use multiple IP addresses to distribute the load across CPU cores on the receiver side, Hercules uses a single congestion controlled flow, which is fairer to concurrent transmissions. When we start the sender, the receiver starts to prepare for the file transmission. This involves warming up some caches, such that the receiver is not overwhelmed when the data comes in at high speeds. We can see the current transfer rate in this column, and with a peak of 97.9 gigabits per second. Alright, let's move to the real world use case. We integrated Hercules as a module into SCION FTP. We will download research data from PSI to our server at ETH. In theory, the bottleneck in this scenario is the uplink at PSI, but can we make use of the full 10 gigabits per second? This is the server at ETH. Let's connect to the SCION FTP server at PSI. Log in and start the download. And you can see Hercules can make use of the full 10 gigabits per second. How does this compare to a traditional transfer? As a baseline we use wget with the mirror flag. The TCP connection is reused and all files are transferred through a single TCP flow. But as we have seen before, TCP needs tweaking on both the sender and the receiver in order to achieve high throughputs. For this video, we compare the performance using a publicly available dataset of about 70 gigabytes consisting of 7,200 files, as shown on the next slide. Now, since Hercules is good at transferring big files, we create a tar archive of the entire dataset and offer that on our SCION FTP server. Here's the result. The plot shows the overall completion time for wget. For Hercules, we show the breakdown into transfer time and the time it takes to extract the files from the archive. Now, including the extraction time, we arrive at a speedup of 2.5. That's it for today. Thanks for watching.